Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Muhammad Fatul Norman bin Muhammad Nazim and my metric number is CE190244. So for today, I would like to present our project, our group project. So our group project title is problem for PBL. So before we go to the simulation video, first thing first, I would like to make a presentation on introduction of PID. So PID is a controller that provides a continuous variation of output within a control loop feedback mechanism to accurately control the process, removing oscillation and increase process efficiently. PID controller is used to minimize the oscillation characteristic of on and off control. PID control goes that bit further to reduce error and provide accuracy and stability in a process. It does this by using the integral action and derivative action to eliminate control deviation, error, and manage rapid process movement. All three PID terms need to tune appropriately for the application requirement to achieve the most accurate control. For high level of control, the digital PID controller are often used. These typically come in the form of PID temperature controller or PID process controller and can be single, dual or multi-loop instrument. So PID control is used for a variety of process variables such as temperature, flow and pressure. Typically, challenging applications such as industrial heat treatment process, oven and furnaces use PID controller, as well as in the scientific and lab sector where precision and reliability is essential to the quality of a control application. So that's all from my part. Thank you. Assalamualaikum warahmatullahi wabarakatuh and my name is Muhammad Fatul Norman bin Muhammad Nazim and my number is CE1904. So right now I will do a simulation on the controller. So first of all, we need to do a setting for our value. So the value of the parameter, we can get it from the question given. So first we do the coding for both of value and then we click run. So after that, so then we go to the menu and then we create a key controller diagram. So here at we will set the step time to 1 and then at the controller we choose a key controller and then at the subsystem we do a diagram for the subsystem controller. So over here what we get is at the first game we have 1 divided by R, then at the second game we have NG times KG times NM times KT divided by R and P. At the third game we have 1 divided by bracket M plus NG plus N times N plus NG times KG times KG times M divided by bracket RMP close bracket close bracket. And then over here at the transfer function block we have 1 over S, and also over here at the transfer function block we have 1 over S. So then at a VEQ at gain over here we have VEQ, and for another gain over here we have KG divided by RMP, and then we have KN. So after we put this subsystem of the controller diagram, we run it, we click run over here, and then after it done run, we go back to the front of it, and then we click run also. So there, VM over here. So this is our graph for VM. So next one, you can see this is a graph for our x1 and x of our graph for x. So what we want to do next is to go to the controller over here, and then we will click here. Then after we click the Q, you can see there are graph will appear over here. So it's graph for reference tracking, that for reference tracking. So for the straight one, it's got a team response, and the dot one, the dot line over here is what we call a dot response. So that's it for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, Doctor, and to all my friends. My name is Nurul Hasanah binti Muhammad Yusof. My matrix number CE190037, and I am from Group 8. Okay. This is our simulating diagram of PI controller. So we need to construct this diagram to get the final result. Okay, this is component, this is step component, this is some parameters, controller, VM, subsystem, X1 and X. Okay, this is a block parameter step. So we set the final value 0.008 and sample time 1. Okay. Then this is a subsystem. We construct this for the controller to get the final result. Okay. This is the formula that we use for subsystem in the subsystem. Okay. So we go to the coding of MATLAB that we use. This is the coding parameter for Decimoto, and this is also the coding for value. The value that we use in this coding MATLAB is based on the question given. Okay, next, so we run this coding. Then we run coding for value also. Okay, after run the coding, we go to the simulating diagram, PI controller. So we run this also. We click at the VM. So this is the output graph for VM. This is output graph of VM for PI controller, and this is output graph of X1 for PI controller, and this is output graph of X for PI controller. And then we want to get the result for auto tuning of PI controller. So we click here. So we choose the PI controller, and then we click the tune. This is our auto tuning of PI controller. This is the show parameter. This is parameter for this graph. For this auto tuning PI controller. Okay, that's all from me. Thank you.
A very good evening to our doctor and to all my friends. Today I'm going to talk about PD and PDI controller in our control system project. As we know, PD stands for proportional derivative and PDI stands for proportional integrate derivative. Now let's look on our diagram that we construct in our own idea. In the diagram, there is step, sum of perimeter, controller, Vn, subsystem, x1 and x. Before we simulate the diagram, we need to know three important things where we need to set our final value and draw the controller in our subsystem, and also we need to construct coding simulation for run the diagram. As you know, our final value is 0.008 is given in our instruction, and here that we construct the value for the subsystem. And here is the coding that we construct for perimeter, DC motor, and also the value that given in the instruction. Now we run it. Once we run the value and the value perimeter, now we can start to simulate the diagram. Here is the references tracking, and we can see that block response and tune response, and here is the perimeter for the PD controller. Now we're going to look on PDI controller. The same diagram that we're going to use to simulate the PDI controller, we just change the PDI in the controller. We double click in the controller, we choose PDI, apply, and OK. Now I'm going to run the PDI diagram. Okay, now you're going to see the output for Vn, x1 and x. Here is the same output for Vn, PDI and PD, not different. Here is a bit different for our x1 and x, a bit different. Here is the references tracking for PDI controller. There is block response and tune response. Now you're going to see the perimeter for PDI controller. This is the perimeter for PDI controller. That's all from me. Thank you.
Assalamualaikum and hi, my name is Wan Muhammad Aslam bin Asri, and my metric number is CE190007, and I from group 8. For the conclusion for this project is, the first is, from this project we know how to explain and solve control system engineering problem using control system theory, technique and concept. And the second is, we use MATLAB software to display the result, what we get, and can know if have a problem, what can solve in control system. The third is, we know how to demonstrate the importance of classical and modern control system in current technology for sustainable development. And the fourth is, we also know the advantage and disadvantage of PID control is in control system.